Hello everyone, I'm Sahil and I'll be covering chapter 1 of chemistry, class 11, that is basic concepts of chemistry, and in 6 videos and including this one. This is my first video. The first topic is the nature of matter. But before starting that, we need to understand what chemistry is and why is it important for us to study chemistry. So, chemistry is the science that deals with the composition, structure, and properties of matter. These aspects can be best described and understood in terms of basic constituents of matter that you are very familiar with, atoms and molecules. That is why the chemistry is also sometimes known as the science of atoms and molecules. Now, why it is important for us to study chemistry? Like, the chemistry plays a central role in science and is often intertwined with other branches of sciences like physics, biology, geology, etc. Also, chemistry plays a very important role in our daily life. On the other hand, the chemical principles are important in diverse areas such as weather patterns, functioning of brain, and operation of a computer. And the chemical industries that are manufacturing fertilizers, alkali acids, salts, dyes, polymers, drugs, soaps, detergents, metal, alloys, and other inorganic and organic chemicals, including new materials, contribute in a very big way to our national economy. So, these are the things. That is why these are the aspects that are important, and that is why we need to study chemistry. Moving on to our first topic of today, that is nature of matter and what is matter. So, what is matter? You must be familiar with this term matter from your earlier classes, but let me try to explain it. Anything that has mass, that has a fixed mass and occupy, not fixed mass, that has mass and occupies space and can be felt by one or more senses that are hearing ability, the taste, the smell, the touch, and the sight. These are our senses. Is called matter. Everything around us, for example, book, pen, pencil, water, air, all the living beings, etc., are composed of matter. Now, the matter can be classified on the basis of physical properties and on the basis of chemical properties. But let's start with the on the basis of physical properties. You are also aware that matter can exist in three physical states, that is solid, liquid, and gases. The constituent particles of matter in these three states can be represented and are represented as I have shown in the figure. So, talking about the solids, in solids, these particles are held very close to each other and in an orderly fashion, and there is not much freedom of movement. As you can see, they are very close to each other, and the freedom of movement is restricted for each atom. Talking about the liquid particles are close to each other, but they can move around. However, in gases, the particles are far apart as compared to those of solids and liquid, and their movement is easily and very fast. Because of such a arrangement of particles, different states of matter exhibit and they exhibit different characteristics. Talking about solids, solids have definite volume and definite shape. Liquids have definite volume but no definite shape. They just take the shape of the container in which they are placed. And if we talk about gases, they neither have definite volume nor the definite shape. They completely occupy the container in which they are placed. Also, these states of matter are interchangeable. That is, a solid can be converted into a liquid by heating the solid, and the liquid can be converted back into the solid by just cooling the liquid. Also, the liquid can be converted into a gas by heating the gas, and the gas can be converted back into the liquid by cooling the gas. Now, these can also be interconverted by changing the pressure of the substance, and we can convert one state of matter into the other state of matter. Now, moving forward, classification of matter on the basis of chemical properties. So, at the macroscopic level, at the bulk level, matter can be classified into mixtures and pure substances, and the mixtures can be further classified into homogeneous mixture and heterogeneous mixture, and pure substances can be further classified into elements and compound. So, what are mixtures? A mixture may be a homogeneous or a heterogeneous mixture. Many of the substances present around us are mixtures. For example, sugar solution in water, air, tea are all the mixtures. A mixture contains two or more substances present in it in any ratio. The ratio is not fixed over here, which are called its component. The components are what? The a mixture that mixture has two or more substances, and these substances are called the components of the mixture. A mixture, as I told you, can be a homogeneous mixture or a heterogeneous mixture. Now, in a homogeneous mixture, the components completely mix with each other and its composition is uniform throughout. The examples are sugar solution of and air. Talking about the heterogeneous mixtures, the composition is not uniform over here throughout, and sometimes the different components can be observed. For example, the mixture of a salt and sugar grains and pulses along with some dirt. You can think of many more examples of mixtures which you come across in daily life. It is worthwhile to mention here that the components of a mixture can be separated by using physical methods such as hand picking, filtration, crystallization, and distillation. Pure substances. Now we'll be talking about pure substances moving forward. So pure substances have characteristics different from the mixture. They have fixed composition, whereas mixtures may contain the components in any ratio and their composition is variable. For example, copper, silver, gold, water, glucose are some examples of pure substances. Glucose contains carbon and hydrogen and oxygen in a fixed ratio and thus, like other pure substances, has a fixed composition. Also, the constituents of pure substance cannot be separated by the physical methods. Pure substances can be further classified into elements and compound. An element consists of only one type of particle. These particles may be atoms and molecules. You may be familiar with atoms and molecules from your previous classes. However, also sodium, copper, silver, hydrogen, oxygen, etc. are some examples of element. They all contain atoms of one type. However, the atoms in different elements are different in nature. Some elements such as sodium or copper contain single atom held together by as their constituents particle, whereas in some others two or more atoms combine to give molecules of the element. Thus, hydrogen, nitrogen, and oxygen gases consist of molecules in which two atoms combine to give their respective molecules. When two or more atoms of a different element combine, the molecule of a compound is obtained. The examples of some compounds are water, ammonia, carbon dioxide, and sugar, and etc. The molecules of water and carbon dioxide are represented in the figure. Moving forward, the next topic is properties of matter and their measurements. So, no, we're going to talk about first the difference between physical properties and the chemical properties. So these properties, physical properties are those properties which can be measured or observed without changing the identity or the composition of the substance. Some example of physical properties are color, order, melting point, boiling point, density, etc. The measurement or observations of chemical properties require a chemical change to occur. The examples of chemical properties are characteristic reaction of different substances. These include acidity, basicity, and the combustibility. Now, we'll be moving further. The measure. No. Okay, so we'll be talking about the measurement now. How do we measure these quantities, the physical quantities? Two different systems of measurement, that is the English system and the metric system, were being used in different parts of the world. The metric system, which originated in France in late 18th century, was more convenient and is based on the decimal system. The need of a common standard system was being felt by the scientific community. Such a system was established in 1960 and is discussed in detail in the coming slides. So, the International System of Units, that is SI units. This system was established by the 11th Journey Conference on Weights and Measures, and the SI system has 7 base units, and they are listed in the table over here. That is length and meter. These are the base quantities. These are the name of the SI units, and these are the symbols for the name. So base quantity over here is length, and the name is meter, symbol is M. Mass, the name is kilogram, the symbol is kg. Time, for time we have seconds and the symbol is S. For electric current we have ampere and the symbol is A. Temperature we have Kelvin, that is K. Amount of substance we calculate in mole and the symbol is MOL. Luminous intensity candela, and that is the symbol is CD. Moving forward, now to talk about mass and weight. So mass of substance is the amount of matter present in it, while weight is the force exerted by the gravity on the object. The mass of a substance is constant, whereas its weight may vary from one place to another due to the change in gravity. You should be careful in using these terms. The mass of a substance can be determined very accurately in the laboratory by using an analytical balance, and which is shown in the figure. Also, the mass of a substance can be sorry. The SI unit of mass is kilogram. However, its fraction gram, that is 1 kg per 1000 gram, is used in laboratories due to smaller amounts of chemical used in chemical reactions. Moving forward, the next topic is volume. So volume has the units length cube. So in SI system, volume has units meter cube, but again in chemistry laboratory, smaller volumes are used, hence volume is often denoted in centimeter cube or dm cube. A common unit, liter, which is not an SI unit, is used for measurement of volume of liquids. 1 liter is 1000 ml and 1000 centimeter cube is 1 dm cube. Also, 1 meter cube is 1000 liters. Now we'll talk about density. Density is nothing but density of a substance is nothing but the amount of mass per unit volume. So SI unit density can be obtained by just simply dividing the SI unit of mass and the SI unit of volume, that is kg by meter cube or kg per meter cube. The unit is quite large and a chemist often expresses density in gram per centimeter cube, where the mass is expressed in gram and the volume is expressed in centimeter cube. Now, temperature. So there are three common scales of temperature, that is degree Celsius, degree Fahrenheit and Kelvin. We don't use the degree word before Kelvin. Here Kelvin is the SI unit. Thermometers based on these scales are like we have thermometers that are based on different scales and that can measure in degree Celsius, degree Fahrenheit and Kelvin. Generally the thermometer with Celsius scales are calibrated from 0 to 100, where these two temperatures are the freezing point and the boiling point of water respectively. The Fahrenheit scale is represented between 32 to 1200 212, and there are different relationships which through them we can convert from one scale to another scale. Like for if we want to convert Fahrenheit into Celsius, we have this relationship, that is degree Fahrenheit is equal to 9 by 5 times degree Celsius plus 32. I'm very sorry that I have written over here 9 by 2, it is 9 by 5. You can correct it by your own. The Kelvin scale is related to Celsius scale in a very simple linear equation, that is Kelvin is equal to degree Celsius plus 273.15. These are the practical relevance. You have to study this on your own. I'll be providing you with the slides in a link, so you can study the practical relevance. Thank you.